Okay, so for this circuit, we want to find out the total impedance, and we have 4 individual components. And we know all these components, they are connected in series. So that means we can just find individual impedances, and by adding them all, we can get the overall total impedance. And we want to express the total impedance in both rectangular form and polar form, and then we draw impedance diagram. All right. So first, let's look at all those individual impedances. For the resistor, we know the impedance is equal to just its resistance. Okay, so it's 470 ohms. And for the inductor L1, so ZL1 is equal to, it's an inductor, so it's J XL1, and XL we know is equal to 2 pi f, right? So it's 2 pi f L, and in this case L1. So it's J 2 pi times f is equal to 1K hertz. 1K is 1,000 times L1 is 47 millihenry. So it's 47 times 10 to the power of negative 3. Okay. All right. 1,000 and 10 to the power of negative 3 cancel. So it becomes J 2 pi times 47. Okay. So it's equal to J 295.3 ohms. Okay. So that's for the impedance for L1. And impedance for L2, L2 is also an inductor, so we can just use the same thing, JXL2. So it's J 2 pi FL2. So it's equal to J 2 pi times 1K is 10 to the power of 3 times inductance is 200 millihenry times 10 to the power of negative 3. Okay. All right. So this cancel. So it becomes J 400 pi, and if you multiply pi, you will have J 1 2 5 6.6 ohms. Okay, so that's for the second inductor, and then for the capacitor, we know capacitor we have ZC equal to negative J XC. Okay, so it's negative J. C we know is equal to 1 over 2 pi FC. Okay, so it's equal to negative J 1 over 2 pi, F is 1K, is 10 to the power of 3, times C, you see C is a 0. Micro, so it's 0.1 times, micro is equal to negative 6, okay? So if you do the calculation, this becomes 10 to the power of negative 3. So, anyway, so if you multiply all these values together, you will have negative J times 1591.5 ohms. Okay, so that will be the impedance for the capacitor. All right, so we want to find out the total impedance, which is ZT. And we know ZT because the circuit is connected in series. That means we just add all these values together. We can get the total impedance. So it's equal to ZR plus ZL1 plus ZL2 plus ZC. Okay, so we just add all these values together, and ZR is 70 omega plus ZL1 is J295.3 omega plus ZL2 is J1256.6 omega, and ZC is a negative, so it's minus J1591.5 omega. Okay, so you can see we have 1, 2, 3 items with J. So you just combine all those three J items together. So we have 470 ohms plus actually it's minus J 39.6 ohm. So that will be the total impedance in rectangular form. Okay? And then in polar form, ZT in polar form, remember how can we convert between rectangular form and polar form? We have this X and Y. So in polar form, it will be X 470 squared plus this negative 39.6 squared. That's the amplitude with angle negative 39.6 over 470. So this will be the angle. And again, if you do the calculation, it's equal to 471.7 ohms with an angle of negative 4.82 degrees. So this will be the total impedance in polar form, in rectangular form, and in polar form. Okay. All right. So once we have this, we can draw an impedance diagram. So for the impedance diagram, for the impedance diagram, the horizontal is for the real, and the imaginary is for the vertical. Okay. So this Z, I, M, and Z, R. Okay. That's for the real, RE. Okay. We use RE for the real and IM for imaginary. Okay. All right. So for this case, the real part is 470. So if we put 470 here, this R equal to 470 ohms, and then you see the imaginary part is negative 39 J. Okay, so it's about here. It's XC. That's negative J 39.6 ohms. All right, so you can see if we start from this point, if we draw a line here, that will be the total impedance ZT. Okay, because for ZT we have this R and imaginary.